Okay, so back a couple lessons to the binomial distribution, which was a while ago now. Do you remember this with the this guy here? So you go if you want to know like if there's a 90% chance of something happening, right? And that means there's a 10% chance of it not happening. And I want to figure out like how many successes you have. If there's 11 trials, you want to know the probability of having 7 successes. And we use the binomial formula, that's 7, and then this will be to the power of 4, right? 11. So you have 7 successes, 4 failures. So there's the P, Q, remember that? 1 minus P is Q. So that's the binomial distribution. So we did that a couple lessons ago. And then we can do that. So here's a situation where we're talking about the number of heads we might get if we flip a coin 5 times. And in this case, P is 0.5, and so is Q. Right, because it's 1 minus P, and that's 0.5. And then if I went through this and I said, what's the probability of getting exactly 4 heads in 5 flips? You would have 5 trials. You want 4 successes. P is 0.5, 4 to the power of 4, because there's 4 trials, or sorry, 4 successes and 1 failure. So that would make this a 1. And you would figure it out, and that's 16%. Okay? So we could do this all the way through and figure out all this stuff. And if I said, what's the probability of getting at least 4 heads? What you could do is figure out 4 heads and 5 heads. Or if I said up to 4 heads, you would figure out this and this and this and this and add them together. But what we found is that we can actually take this data, and if you take this data and plot it, it's going to be somewhat of a normal curve. Okay, even if it's a little bit skewed left or right, which it definitely can be, we can still approximate it using the normal curve and using z-scores. So we can do that, and it makes our life a lot easier as long as we pass this simple test. So we need that the NP and QP are greater than 5. So the reason that's the case is, think about this. We have N and P. They have to be greater than 5. One way to get that to be greater than 5 is to have N big. So if we do a lot of trials, so if you have a lot of trials, that's going to make this bigger. Okay. The other way to make this not small is if P is extreme. Let's show how we could fail this test. If we have a small number of elements, that's going to be small. That's going to be less than 5. Okay. So if I had 6 trials, let's say, and I have a 30%, then I do that. That's 1.8. I'm not going to pass. Even if I have a 90%, no, 80%. Okay. Even that case, it's too small. Okay. So NP and NQ both have to be greater than 5. So you either have a big N, and you definitely don't want extreme P's or Q's. So if things don't happen that often, what you're going to end up having is a very skewed graph. And in that case, we're going to admit that, look, something that looks like that, not like that, but something like really skewed is not going to be normal. And if it's not normal, we can't use the normal curve to approximate it. But if it does pass both tests, then we can move on, and we use a Z-score like this, and then we use the probability of success is P. And then what you have to do is find mu and sigma for this z-score, and the z-score for mu is n times p, and for sigma it's the root of npq. So once we have those, we pass the test and we have those formulas, we can just use this stuff. It's kind of cool. So if in this case we have 24% of the loans are going to be delinquent, so we're going to call delinquent a success. Okay. So here, if we want to say that the rate of delinquency is 24%, 0.24, that's my P, then that would make Q 1 minus that, which is 76%. And what I want to do is, if I have 200 loans, which is my N, the question is, what's the probability that at least 60% of them are delinquent? So let's say the bank gets in trouble if 60 of the 200 are delinquent. So delinquent means that they're behind in their payments. So we want to do that. Find that out. What we do is we find mu, and to find mu, we do N times P. So that's 200 times 0.24, which is 48. And then we do the root of NPQ to get sigma, which is the following. Now, we could have done this first. Do we pass the test? NP, is that greater than 5? Yeah, it is. NQ, is that greater than 5? Yeah, it is. So we can do this. Okay, so what we want to do is find the probability that X is greater than 60. So let's change it to Z-score. So find the Z-score. There is so back up top, there is your X. That is your mu. That is your sigma. You plug those in, 60, 48, and 6, and you get a Z-score of 2. So now I want to find on a Z-score, Z-table, a normalized table, what is greater than 2. Okay, so back to when we're doing our Z-scores, you have something like this. There's 2 like that. So remember how to do this. What you want to do is find the probability. We can't do that directly. What we do is we find the unshaded area right here, which is 1 minus the probability that Z is less than 2. Sorry, less than 2. Okay, so so that's the unshaded area. Sorry, and you subtract that from 1. You get that off the off your old chart. So go back to the z-score chart and find what 2 is, 0.9772, and subtract from 1, which gives us 0.2878, which is 2.8%. So that is that question. The next one is similar to it. Okay, you got to go ahead and, in this case, you're given P and you're given Q. They pass the test, both of them. Here you have, what's the probability that 25 people like this cola? Okay, there's 70 people in the mall. There's your N. And you want to know 25, that's going to be your X. Okay, so we have to find N, P, Q. What's mu? So N is 42, Q is 58, 1 minus that. Mu is going to be this, N times P. Sigma is going to be the root of NPQ, which is that. We passed the test, we found mu, we found sigma. Now I want the probability that X is greater than 25. So I want, no, less than 25. Sorry, less than 25. So I want the probability that fewer than 25 people will choose Queen Cola. So change that to a Z-score. There's your X is 25. Your mu is this. Your sigma is that. And then you figure out that that is negative 1.07. So I want the probability that Z is less than 1.07, negative 1.07. So that is going to be on a, like if you sketch it, you're going to be on the left side of the curve. So I want the shaded area here and just look that right up. The second part is this. What's the probability that exactly 25 people will do that? And we can't find that from what we're doing, okay? Because when we look at the table, it's always less than or greater than, but you can't get an exact number. So if you go back a few lessons, we kind of talked about that. This is just an approximation. So if you actually do this sort of thing, in theory, it's a messed up thing, but in theory, exactly 25 people will be 0. Now, you could do this with a binomial distribution. So to do this, what I would ask you to do, if we were to do this, I'm not going to ask you to do this unit, but it could be a question on the exam. If you were to do this, you have 70 people and 25 are success, right? So then you would go ahead and go 0.42 to the power of 25 and 0.58 to the power of 45. Okay, so why is it 25 and 45? There's your 25. 70 subtract 25 is going to be 45. Now, I'm not going to ask you to do that right now, but just to, I do want to show this. We have fewer, we have less than, we have greater than. We might even have extremes, like, right, where we've done questions like this, you know, find the shaded area or find the non-shaded area. Okay, we can do all that, but we can't find an exact number using Z-scores. Okay, but I won't ask you that, but just to go over that. And that, I believe, is it. Just some homework there on that, and we're all done. All right, that's the unit. Maybe a little difficult at the end, but just give it a go. It's not too bad once you get in there.